Hi everyone, welcome back to the channel, and today I'm going to give you a quick overview of how a microservice-based architecture works. Now, microservices have indeed fallen in and out of fashion in the last few years, but regardless of the current opinion, it helps to understand why they evolved in the first place. So let's take a quick trip down memory lane and see how we got here. Back in the day, building an application was pretty straightforward. You just bundled everything into one big chunk of code. This all-in-one or monolith approach handled everything. Data storage, business logic, user interfaces, you name it. It was simple, but as apps grew more complex, this method started to show its cracks. To troubleshoot and scale an application, engineers first had to analyze and refactor the dependencies, which felt like untangling a massive knot of wires. So microservices evolved to solve this problem by breaking down that monolith into smaller independent services. Each service then handles a specific piece of functionality like billing, inventory, or user management. One of the key benefits of microservices is that they allow you to develop, deploy, and scale each service independently. And you can even write them in different programming languages. But with great power comes great responsibility. And as you break things apart, the communication between these services can get complex, especially in a distributed system where services might be running on different servers or even in different regions. And if you're using REST APIs or other point-to-point connections, the system can get blocked if one part is down or doesn't respond in time. And that's where message brokers like Apache Kafka or RabbitMQ come into play. Message brokers enable your microservices to communicate asynchronously. So instead of services waiting on each other to respond, they publish messages to a topic or to a queue, and other services can consume those messages whenever they're ready. This decouples your services and helps to prevent bottlenecks, especially when scaling. So for example, even if your inventory service is temporarily down, orders can still be placed and the inventory updates can still be processed later when the service is back online. Now, let's look at some best practices to take into account when designing microservices. Define clear boundaries. Each service should have a well-defined boundary responsible for one specific business capability. Try to avoid services that are too large or too small, and try to find the right balance. Embrace asynchronous communication. Whenever possible, use asynchronous messaging like Kafka or another queuing system to keep your services decoupled. This reduces dependencies between services and increases the resilience of your application generally. Handle failures gracefully. In a distributed system, failures are going to happen, so you need to plan for them. For example, you can use Kafka's durable message storage to replay events if a service goes down and needs to recover. Keep data decentralized. Each microservice should own its data. This means no sharing databases across services. This practice helps to maintain service independence and consistency. Now, before we wrap up, I want to touch on something important: choosing the right communication pattern. In discussions about messaging, you'll often hear about two main patterns: message queues and publish, subscribe, or pub sub. Understanding the difference between these can help you design your microservices more effectively. In a message queue, messages are sent to a queue, and each message is typically processed by only one consumer. This pattern is useful when you have tasks that need to be processed independently by different services. For example, you might use a message queue to distribute tasks across several instances of a service to balance the load, like processing orders during a high-traffic event. On the other hand, pub sub allows multiple services to subscribe to the same topic and receive the same messages. This pattern is ideal when you need to notify multiple services about an event. For instance, when an order is placed, both the SMS and emailing services can be notified simultaneously, so that they can then notify the customer in turn about the progress of an order. And Kafka excels at this because it allows multiple consumers to read from the same topic without interfering with each other. So when should you use one over the other? If you need to distribute tasks to different workers and ensure that each task is processed only once, a message queue is the way to go. But if you want to broadcast an event to multiple services so they can all react to it in their own way, pub sub is the better choice. But remember, the right choice depends on your specific use case and the behavior that you need from your system. If you need more help deciding what patterns to use and what tools to select, we've actually published a free ebook that can help you with that. Just use the download link below to get your own copy. And with that, Thanks for watching, and if you found this video helpful, make sure to hit the like button and subscribe for more educational content. And if you're using Kafka to process data and coding in Python, or if you're considering Kafka, drop a comment below. I'd love to hear about your experience. Thanks for watching, and see you in the next video.